5, 4, 3, 2,
1.
Hello and welcome to Slooh, especially Slooh members watching on the live channel. Now, don't forget you can snap images using the StarShare camera below the show's video panel, and you can also use the chat box to the right if you want to ask any questions. That's Slooh members watching on the live channel. There we go, a nice constellation cam. I'll show you that in a second. So, what are we doing tonight? Well, last week we brought you Mars at opposition, the night when the planet Mars is directly in line with the Earth and the Sun. Kind of a similar arrangement to what happens in a full moon. Now then, you can ask us questions, send us your comments, or even your own images to @Slooh. So if you're not a Slooh member, you can send us a question there. Now, we've got some live views of the red planet tonight from our flagship observatory here at the Institute of Astrophysics of the Canary Islands. Now, first of all, we're going to take a look at the various live feeds that we've got. We've got this one here is the constellation cam. Now, this gives us this lovely wide field of view, and just to the left there, that bright, lovely orangey red color, that is Mars. And then further up the image to the right, you've got the bright star Antares. That's the heart of Scorpius, the constellation Scorpius. And then just down in the bottom right-hand corner, you can see the beautiful ringed planet Saturn. Now, we're going to have some fabulous close-up shots of that for you in an upcoming show, so we'll tell you about that a little bit later. So we've also got our 17-inch telescope tonight, giving us some live views of Mars as well. Now, this Mars, because it's so close to us, it's incredibly bright. So these images are a little bit blown out, but we'll keep an eye on those throughout the night, because we did see some lovely dark features on the face of Mars down at the bottom. And that's, yeah, the next image will come up color. We also have, we had our solar system, our new telescope, our new solar system telescope coming online tonight, but we had a couple of issues just before the show, but we have got some wonderful captures that we made earlier, and they look absolutely fabulous. So we'll get one of my guests to talk about that. So anyway, Mars, the red planet. You would think, wouldn't you, that we'd know all there is to know about our planetary neighbor. But, you know, new discoveries are being made virtually every week from the various Mars missions that are currently underway. So is that dusty red planet dead? Did it ever harbor life? And maybe more importantly, could it at some point in the near future harbor human life? We certainly hope so here at Slooh. So how have humans throughout history and into the modern age seen and understood the planet Mars? Well, all of these questions we are going to be answering for you tonight about that rusty old planet in the next hour. And to help me do that, I would like to welcome Slooh astronomer Bob Berman to the show. Bob, thank you for joining us tonight for this special Mars show.
Paul, it's a pleasure to be here.
And now, Bob, I did promise everyone that you would maybe take us through this constellation cam image a little bit more, so we can see Mars down there in the kind of bottom left-hand corner, shining so brightly. And then we've got Saturn down in the bottom right. But can you tell us a little bit more? We've got the head of the Scorpion in the constellation of Scorpius, haven't we?
Yes, and just as proof to everybody that we don't practice these shows and rehearse them ahead of time, let me tell you that I can picture how Mars and Antares and Saturn look these nights, looking at the constellation. I know just to the right of Mars, actually it's now slipping to the left because Mars is still retrograding. We've got Beta, Delta, and Pi Scorpii forming those stingers at the head of the Scorpion, and to their right, the Libra stars, Zubena Shameli, what a funny name, right? And Zuben al-Janubi. But as I'm looking at this, I don't have my orientation here. I'm seeing, you said Saturn was to the right of it, and I think Saturn should be to the left of Mars. That's obviously Mars on the left. This is so new, the constellation camera, that I don't know the
Yeah.
scale. How have we zoomed in? Are these
Okay.
little sixth
What we've
magnitude stars? So I know I'm making a fool of myself. You've turned it over to the
no, not at all,
expert.
Bob,
What are
because
we looking
actually,
at, Bob? And all I'm saying is, I don't know. I mean,
no,
that's
no.
Mars on the
Last
left,
time
obviously.
I helped us out, didn't I, by orientating us? If we turn to the actually it's the left. I think we see it slightly differently um, to our viewers, but we can see there Mars is at the top, kind of thing, and then we've got the three bright stars, forming that head of the Scorpion, and then further off down to the right and above, we've got Antares, and then we've got Saturn all the way down to the left if we're looking at it like that. So anyway,
Oh, I see. So
let's move
it's
on, Bob.
oriented. It's oriented in a very different orientation. Okay, I
Yeah.
get that
So
now.
if
So
we rotate it
feel
around
free
90
to
degrees, we
turn the microphone over to your expert anytime you want to, and for me to tell you I don't know. But it's
no,
gorgeous
it's not
anyway.
like that
We're
at
looking
all.
at Scorpius, certainly. We're looking at the Scorpius Libra border, which is where Mars is sitting. Mars being that big orange thing, the brightest that it's been in 10 years.
So what is it actually, Bob, that gives it that orangey red color? I used the term earlier, rusty old planet. Is that an accurate description of what's been going on and why it's red?
Oh, yes, absolutely. In common with the moon, which is essentially half oxygen, if you've ever wondered what you're looking at when you look at the moon or Mars, really lots and lots of the same oxygen that we breathe in with every breath, except that oxygen is so promiscuous in wanting to combine with anything, almost any
Yeah.
other element around, that it's in the form of, in the case of Mars, you said it, rust, iron oxide. So it's combined with the iron in the soil. And the moon, it's combined mostly with the silicon on the soil, as silicon dioxide, in other words, ordinary sand. There's also a lot of aluminum oxide. And so, yeah, that's why we get that color. The only planet in the solar system that has that, although Mercury is a little bit slightly orangish, but
Oh,
nothing
is
like
it?
Mars.
Oh, okay. And this is unmistakable, isn't it? We may have the all sky image to look at, and that will show us a very easy way of explaining to viewers how they can see both the red planet and Saturn as well, Bob. So when that comes up, maybe you can take us through that, because it is a spectacular sight visually. That it's just so bright and so obviously orange at the moment. It's absolutely beautiful. Now, Mars was originally seen by ancient cultures as a star. When did they kind of finally figure out that it wasn't the same as all of the other
Well,
stars and it
not
was a planet?
until the Renaissance. Certainly, in the time of the ancient Greeks and the Romans, these were regarded as gods made up of godly material circling the Earth, not circling the sun. They would have been astonished to learn that the planets are actually bodies containing the same elements we have on Earth, and that they're going around the sun and not the Earth. So they went from gods to, I mean, planet means, the word means wanderer, because these five objects that they knew of, Mercury, Venus, Mars, Jupiter, and Saturn, move against the background stars, and the other stars are fixed. Ah, look what we've got. Look at that nice color. We call it the
Isn't it
red
beautiful?
planet, but we mentioned this during the opposition last week. But honestly speaking, slooh is capturing the true color of Mars. And I wish we all had
Yeah.
little swatches from a paint store, because if we were matching it up, not only is it not red, but it's not honestly orange either. If you took
It's not,
orange, think
no.
of something that's orange, like an orange. If you saw an orange of this color, well, this is really orange yellow. Yellow orange is the honest color. Not to make a big deal of it, but that's the true color, and that's what we're seeing here.
So what are the dark regions we're seeing on this video capture, Bob?
Yes, the markings on Mars, like Sirius Major, and well, they were so intriguing because they seemed to grow larger when the polar caps shrunk. So for a long time, especially people like Percival Lowell and others late in the 19th century into early in the 20th, were convinced that these were plants, that there could be plant life on Mars. And they kind of had it right in a way because no other planet is remotely as hospitable to
Yeah.
potential life as Mars is. So what we're seeing through our wiggly atmosphere, of course, tonight is our darker albedo features. Mars has is much dimmer than we are. We reflect about 38% of the light that hits us. In other words, our albedo is 38, and the Martian albedo is closer to 20. It's not as dark as the moon, but it's not very reflective. And so all the surface features that we see, rocky, sandy, not shiny things like clouds that we have on Jupiter or on Venus, and not at all shiny features. These are rather dull. Not as dull as Mercury, which takes the prize for being almost as black as coal, but pretty darn dark.
Pretty darn dark. I like that. Now, tonight's show is all about how big the planet is, how close it is. Last week we did the opposition. So, sun behind Earth, Mars straight out in front. But it's taken a week later for Mars to be closest to Earth. So, why that disparity, Bob? And is that the same for all the planets?
Oh, not at all, Paul. Most planets, when we achieve the lineup with the sun and Earth and the planet, when we're in between the planet and the sun, that's usually the very day that the planet is closest to us, or within one day of it. But in the case of Mars, you have to think of things in three dimensions. Here, look at the rounder Earth orbit, those into math. If you were going to consider its orbit, it's has an eccentricity of 0.01. Mars is more like 0.09. And it's much more, look at this, you can see it. It's
Yeah.
much more oval or egg-shaped. Look how the sun is not remotely in the center of the Martian orbit. So when we meet Mars, we can meet it at a narrow separation between our orbits, as we did on August 28th, 2003, when we came closer than we had in 50,000 years. Or look at the upper left of this picture. We can meet it when there's a huge gap between us, and therefore, even though we've waited 2 years and 2 months for this long-awaited close encounter, nonetheless, it's not very close. It's something like 50 million miles away or even more, and it's not very bright. It's not very big in telescopes. So tonight, are we meeting it at its narrowest point or at its widest part? And the answer is no. We're about at an average distance for this meeting. But if you consider the tilt of the Martian axis, tilted about 2 degrees relative to the plane of the solar system, and that big ovalness to it, well, the time that Earth is in between Mars and the sun, look at this drawing. You can really see when are we in between and when are we closest. They're about a week apart. And therefore, tonight is the night of the very closest approach, biggest, brightest, kind of historic. Historic in the sense that biggest in 10 years. It's still only
Well,
18 arc seconds across. Wait till the next time in another 2 years from now in 2018, and then it's going to be over 20 arc seconds, and it's going to be so big we'll almost have to shrink the image to fit it into our cameras.
And
I'm
when
exaggerating, but
when you say 20 arc seconds, Bob, that's the apparent size of its disk, isn't it?
yes, exactly. 1 arc second is the size of a $quarter coin when viewed from 4 miles away. So if somebody 4 miles from you held up a quarter, that coin, that's subtending an angle of 1 arc second. And an arc second is a 60th of an arc minute, and an arc minute is a 60th of a degree. The human eye can see about, if you really have 20/20 vision, a little over 200 arc seconds. So it means that Mars, unfortunately, is 200 times smaller than the tiniest angle you could ever see with the eye. In other words, in one sense, it's microscopic, but to use the correct term, you need a telescope to amplify it quite a bit to see, even see it as a circle, a disk, and let alone to see features within it. And this high
Oh,
magnification
look at
is what's
this, Bob.
causing this turbulence tonight.
That's a cracking image coming in. This is from the 17-inch telescope live from the Canary Islands Observatory. That's a beautiful image. So Slooh members, don't forget, use the StarShare camera if you're watching at slooh.com to snap your own images of this. Bob, you know, I'm, you know me, I'm a great one for making time-lapse animations. And obviously my favorite planet to do that with is Jupiter, because it rotates once every just about 10 hours, just under 10 hours. So over a whole night, you know, I can capture the vast majority of Jupiter in a time lapse. How easy is it to do that with Mars? Because how long does a day on Mars last?
Yeah. A Martian is 24 hours, 37 minutes, and 23 seconds. You know, I memorized that when I was in high school, and I've been waiting over 40 years for somebody to ask me that so I could finally spit that out. So, in other words, it's about half an hour longer than an Earth day. And that's unfortunate because that means if you watch Mars at the same time each night, and we tend to, you know, if you have a backyard telescope, you might want to see it at 8 or 9 or 10 o'clock. You probably won't be watching it at 4 in the morning. The next night at that same hour, Mars is only rotated a half an hour differently
Right, of
from
course.
our rotation. So essentially, you're going to see the same face, the same
Yeah.
features as you did the night before.
I hadn't ever considered that, you know, and you know, as I say, I'm a great Jupiter fan, and you know, you look at it every night, observe it every night with the Slooh telescopes, and there's always something new to see. Some nights you get the great red spot, other times you get a lot of the moons maybe transiting across the planet. So, okay, that's an interesting one. So that's a day on Mars, but how long did you say a year was? So, in other words, how long does it take to orbit the sun, Bob?
Yes, about 2 years, 687 days. I remember about 2 years. And the thing that really prolongs that, unfortunately, is that as we're watching it revolve around the sun, we too are going around the sun. So once we've caught up to it, as we are tonight, looking at it quite close, when we go around 1 year and return to our starting point, Mars, which moves about half our speed, has moved around to the other side. So we have to then do another half of our orbit to try to catch it. But meantime, while we do that, Mars has moved another quarter of its orbit. And so it's like the tortoise and the hare.
Okay.
It's like the old
Yep,
Greek.
yep.
You know, by that logic, we'll never catch it, of course. It'll always be a little bit ahead of us. In truth, we catch up to it again in 26 months from the first time. Oh, I love this graphic
It is
that
a
you
great
have here.
diagram. So take us through this, Bob, because this is showing us that we've got something really to look forward to in 2018. Maybe if we can just whip the live image off that diagram for a second. So take us through
Yes.
this, Bob. What are we looking at?
Yes, and this is very accurately shown, Paul. It really shows the difference in our orbits. Look at the topmost image. That is, we're looking at it as it was at opposition a week
Last
ago. And look at the gap between the two of us and the magnitude, you know, the lower the number, the brighter, of course. So it's minus 2.1. Now we wait for 2 years, 2 months. We said that's the time for us to catch it again. And that's July of 2018. Look how much brighter. Minus 2.8 instead of minus 2.1 means that's brighter than Jupiter. And so we're meeting it at a really, really close, narrow separation. 2 years and 2 months after that, look at that, October of 2020, the gap starts to widen again, but it's still quite good, still even better than this one, magnitude minus 2.6. And then the one after that in December of 2022, now the gap starts to widen. We don't see Mars as well. But the good news there, at least, is that it's up in the constellation of Gemini, for that one, and that's high up in the sky, almost overhead, for us observers who live in the northern hemisphere. I guess not for
Excellent.
us observers, for we observers, right? Well, which is correct grammatically. Let's not get distracted.
For
Canadians,
yes, because
Americans,
actually I do
Europeans,
want to
all
point
of
out
us
the
who are
other
north of the equator,
the
that will be very favorable because Mars will be high. This one's very low in the sky, but it's closer. So you kind of have to choose your poison. Do you want Mars to look bigger and clearer, but lower in the sky where you have to look through more thick, wiggly air? Or do you want it higher in the sky but smaller? And just this diagram shows what's going to happen, each of the conditions for the coming oppositions.
and for viewers there, the numbers in brackets that say AU after them, that's an astronomical unit. That's the mean distance, isn't it, between Earth and Sun, Bob?
Yes, exactly. Earth being exactly 1 by definition, Mars on average being 1.52 astronomical units. In other words, 1.5 Earth distances from the sun. Picture that and you pretty much have it. That's why all the planets, the first 4, are so close to each other. Mercury is 0.4 of an astronomical unit, 4/10 of our distance. Venus is 0.7. Mars, as we said, is 1.5. And then after that, all heck breaks loose. Uh, Jupiter is 5.2 AUs. Saturn is 9.5. Uranus is all the way out at 19. And so you have the wide open spaces, huge distances. They're nowhere near us, unlike these first wonderful 4 rocky, Earth-like terrestrial planets, Mars of which being the only one we can realistically hope to land on as humans.
Bob, we've got a question coming in from Twitter, and we touched on this actually with the show last week when Mars was at opposition. As we watch those images, first it comes in black and white, and then they come into color from the 17-inch telescope. What are the major geological differences between the northern and southern hemispheres of Mars, Bob? We talked about this with, the possibility that there was this huge ocean, wasn't there, in the northern hemisphere?
Yes, that's the news that Mars goes through cycles that, especially because its poles. This reader or viewers looking at the talking about the poles. Well, they tilt and vary tremendously on Mars. Here on Earth, our axial tilt only varies by about 2 degrees from the average. We pretty much point the same way. That's thanks to the moon, by the way, which stabilizes our tilt. But Mars has no large moon. It has 2 little tiny pieces of junk. It's got no moon to stabilize that. So the tilt goes crazy and varies by about 90 degrees. And as it does so, there's a huge change in the conditions on Mars, including possibilities of oceans that we think are more and more likely. One of the big differences is that as Mars comes to its closest point to the sun, perihelion versus the farther one, whichever axis is pointing toward the sun at that time makes a difference between its summer and winter that's very different from what we have here. Here on Earth, we're closest to the sun the first week of January, which is when the southern pole of Earth points towards the sun. The northern pole points towards the sun in early July, on or around July 4th every year, when we're farthest from the sun, and that moderates our northern hemisphere. But that's not too crazy a condition because Earth doesn't vary that much. We only the sun only changes its brightness by 7% in our sky. Not for Mars. Mars has a huge difference, and because of that, the poles act very differently in their summer and winter. By and large, the northern pole has more water ice. The southern pole has more dry ice, carbon dioxide.
Right. Okay. Now, Bob, you're going to be coming back a little bit later when we're going to talk more about that strange and mysterious planet that seems to have captured our imaginations more than any other, really. And we'll discuss whether either of us would be interested in visiting the planet. We're lobbying Elon Musk, if he's feeling generous, to give us a ticket on his ride. But when you come back, Bob, I'd also like to ask you, not as a trick question, but something that I know a lot of viewers may have read recently. What is the closest planet to Earth? So mull that over, and let's talk about that when you come back as we watch this latest image pop into color from the 17-inch telescope at the Slooh Canary Islands Observatory. Bob, we'll see you a little bit later.
Okay, great.
Now, don't forget, viewers, you can ask us questions by using the chat box on the live channel at slooh.com or by tweeting to @slooh. Now, we are going to take a quick commercial break, but coming up next, we've got Slooh's mythology expert, Tricia Ennis, who's going to tell us about the importance of Mars in ancient and modern cultures. But first, to all of the viewers out there watching tonight, if you're enjoying what you're seeing, what you're hearing, I really want to encourage you to become a Slooh member of the Slooh community. It's free to try, absolutely no obligation. At its core, members control our robotic telescopes in the Canary Islands and in Chile via this simple but powerful interface to see absolutely everything that glows in space. Members have taken well over 4 million photos of over 50,000 different objects in the sky over the last 12 years or so. Now, Slooh works just like a jukebox. One member is in control of the telescope, so you can be controlling this 17-inch telescope or the half-meter telescope. That's an enormous thing. One member controls the telescope, while all the other members get to see what the telescopes are viewing live, and then everybody can contribute to the ongoing conversation about it. And we always say, we're like cavemen and women gathered around the campfire, and we wonder together about the universe and share our great diversity of perspectives. It really is space for everyone here. So please do give it a try. And in the process, you're supporting our ability to make programs just like this available to the public. Now, don't go anywhere. We will be right back after this short commercial break.
Hello, and welcome back to our Red Planet Rocks broadcast here on Slooh. My name is Tricia Ennis, and as you've probably ascertained by now, tonight is all about the planet Mars. I'm Slooh's resident mythology expert and cultural correspondent, and Mars is a fascinating subject in my world. If you tuned into our Mars opposition broadcast last week, then you heard all about how important the planet was to the ancient cultures of Greece and Rome. For those of you who weren't able to tune in, Slooh members can watch any of our past broadcasts at any time, right on slooh.com. For now, though, here's a quick refresher. Greece and Rome had pretty much the same depiction of Mars, the god of war, but vastly different interpretations. In Greece, he was known as Ares, and was generally looked down upon as a god of unrest and upheaval. In Rome, he was Mars, sound familiar? A warrior god and guardian of the Roman people. Rome got their version from Greece, but they weren't the first cultures to place a great deal of significance on the Red Planet, or, as it appeared to them, the Red Star. In fact, they weren't even the first to regard it as a representation of a god of war. In ancient Mesopotamia, the Babylonians created an astrotheological system, charting the stars and planets and assigning them to figures in their pantheon of gods and goddesses, much like the Greeks and Romans, but quite a lot earlier than they did it. In that system, the planet Mars was associated with the war god Nergal. Nergal was a harsh, destructive force, representing not just war, but pestilence and the harsh, fiery midsummer sun. It's not entirely surprising that they would have identified Mars with this fiery god due to its distinctive red color. Over time, as you might have noticed, we've slowly learned more about Mars. For example, we now know it's a planet rather than a star. We also no longer really associate the planet with any kind of deity, though some people still place a spiritual significance on the movements of all the planets, Mars included. By the time the late 19th century, early 20th century rolled around, we were instead looking up at the stars and wondering whether life might exist on those other planets that we had discovered. Spurred on by a misinterpretation of the early observations of Mars' features, rumors and hypotheses about possibly intelligent Martian civilizations on the planet's surface started to emerge. In 1899, renowned inventor and one of my favorite people in all of history, Nikola Tesla, received repetitive signals on his equipment and determined that it was possible that they were the result of intelligent life coming from somewhere else in the solar system. Tesla's original theories were compounded upon by people like Lord Kelvin, who was the first to suggest that the inhabitants of Mars, it was them trying to communicate with us. And later, Edward Charles Pickering would take that theory to new levels, suggesting that we should build a giant mirrored contraption in order to communicate back to them. While we've never had any kind of confirmation that there has ever been any kind of life on Mars, certainly no intelligent life, speculation about the significance of Martian features continues to this day. But if you want to experience some adventure with the inhabitants of the Red Planet, then fiction is the place to go. Just as the possibility of life on Mars captured the imaginations of scientists and laypeople alike, it also captured those of authors like H.G. Wells, Ray Bradbury, C.S. Lewis, and Edgar Rice Burroughs. Each of these literary figures interpreted the possible civilizations of Mars in some capacity or other. From the Martian invaders of War of the Worlds to the human destruction of the Martian Chronicles, and of course, the civilizations of the famous John Carpenter of Mars pulp novels, which were turned into a wildly unsuccessful Hollywood film a few years ago. As our understanding of the realities of Mars' desert landscape changed over the course of the next few decades, so did our fictional interpretations of the planet. Gone were the Martian civilizations that interact with us Earthlings, and instead, Earthlings were making their way to Mars to set up their own civilizations. From the outposts of Philip K. Dick's Total Recall to the first steps of Andy Weir's The Martian, the Mars of the 20th and 21st centuries has become one of human progress, glory, and manifest destiny. The Mars of the modern era is now the bastion of human expansion into the stars. Paul, back to you.
That was Trisha Ennis, Slooh's resident mythology and cultural expert. So what is your favourite Mars-related movie? You know, I'm not a great film critic like Trisha, but I actually like this film, which is really bad. It's called Ghosts of Mars, but I don't know, there's something about it that I really like. I'm also, like Trisha, actually a Total Recall fan, the original, of course, with Arnie. Anyway, we want to hear from you. Tell us at Slooh, what's your favorite Mars-related movie then? So here we are, viewing Mars at its largest and closest in a decade. The best place to watch, obviously, is at slooh.com, where members can use the StarShare camera to snap their own images from our feeds tonight. Now, I was having a look during Trisha's segment. Sorry, Trish, I wasn't listening. I was having a look in detail at some of the images coming in from the 17-inch telescope, and we can see some pretty nice features there, actually. It looks like we've got some polar cat maybe in one of those. But don't forget, you can also ask us questions, and anybody else can ask us questions by tweeting to @Slooh. You can send us your own images or even your thoughts, poetry, or whatever Mars-related stuff that you want to bring to our attention. Now, let's welcome back Slooh astronomer, everybody's favorite, Bob Berman. Hey, Bob.
Hi, great to be back. Great show.
What did you make of Trisha's segment, and what is your favorite Mars-related movie?
You know, I think I'd have to vote with you. I really liked that first Total Recall as well. And yeah, I'm trying to think of some. There was one a few years ago where astronauts got stranded on Mars as well. I'm also partial to the radio show, The War of the Worlds, read by Orson Welles, and which scared the heck out of everyone who heard it in the New York City, New Jersey area. One of the reasons I'm so partial to that is that it was written by Howard Koch, not well known, who later, almost a decade later, went on to achieve fame by writing the movie Casablanca. And Howard Koch also, in his 90s, as a tall, thin, still handsome man, took one of my astronomy classes. This is decades ago, and asked me to collaborate with him on a book, which we actually did for a while. So because of my connection with him, I love that the radio show that he never really got credit for, because Orson Welles, the one who read it, really got the credit. But that just shows how the War of the Worlds movie, oh, and that, of course, that counts. It wasn't really set on Mars, but the invaders certainly were from Mars. I like both of them, the Tom Cruise remake a few years ago, and the original one with Rod Taylor, I think it was.
That's right. Yeah, it was.
And I thought that was really neat, with those things coming out of the top and sending rays. It was a great 1950s movie. Yeah.
It was. I mean, you watch that film now, actually, and even now you think, wow, they were doing that in the 50s. And I think one of the lovely things with that was when people were lasered or whatever it was by the Martians, all that remained was this kind of little trace of grit and ash on the floor. The Tom Cruise one was a little more visceral, wasn't it? But anyway,
Yes.
now, Bob, I asked you before this question I've seen in the press quite a lot, and there's a lot of confusion about it. And it's when you ask the question, what is Earth's closest planetary neighbor? Now, it's not a trick question, but it kind of can be, can't it?
Well, I guess it could. I mean, those of us who had little wall posters of all the planets when we were kids certainly knows that Venus comes 26 million miles from us, and Mars at its closest is 35 million. So it's really no contest. Venus comes closer than Mars does. The problem is, because it's an inferior planet, not that there's anything wrong with it. I mean, inferior meaning it's inside our orbit. When Venus is closest to us, it's lined up with the sun. And even if it doesn't pass in front of the sun, as we saw back in 2004 and 2012, it's impossible to see because it's lost in solar glare. But when Mars comes closest, as we're seeing tonight, well, then it's opposite the sun. It rises at sunset, is at its highest at midnight or 1 a.m. if it's daylight saving time month, and is best seen when it's closest to us. So because Venus is worst seen at its closest and Mars is best seen at its closest, no wonder people tend to choose Mars, even though it isn't the closest planet.
But also you have the other element that in their orbits, in our little celestial mechanical orbit around the sun, each one of those planets can be closest to us at different times as well. So, Bob, we were going to tell people how they can view this marvelous spectacle of Mars, and in the constellation of Scorpius, with Saturn in there. We've got an all-sky view here. Now, this is a special camera that we have at the observatory, which literally gives us 180-degree field of view. Now, it's orientated so that north is up, so south is down, and this is the kind of view that people will get if they face kind of southeast-ish, isn't it, Bob?
Yes. Now you can turn me loose on this, and yes, of course, now I'm oriented. Now that it's easy. To the bottom left is the teapot of Sagittarius, whose spout on the right side of it represents, you see a little brightening in the Milky Way. That's the center of our galaxy there, so it's very special. The constellation of Scorpius is marked, the brightest thing in the sky on the bottom right is Mars. Just to its left, those three vertical stars, Beta, Delta, and Pi Scorpii, are the stingers of the scorpion. Moving to their lower left, that other orange bright star is Mars, and the bright star just to its upper left is Saturn. So that's really easy. And then the scorpion itself heads down below our red line there, and then curls back up again,
Just see
ending
it,
with the
stinger
fabulous
coming back.
double star Shala on the left and Lasath on the right, or Lambda Scorpii, as it's also known. Gorgeous constellation. You and I were talking about that.
Yeah.
We'd kind of vote on it as the best of the 88 constellations. So that combination of Scorpius and Sagittarius with the center of our galaxy in between them, and then rising up across the sky, you see Vega top center, above the center near the top of the picture. Clearly it's blue color, and the parallelogram of stars just to its lower left, made up of beta, gamma, delta, and epsilon Lyrae. Beautiful. That other bright star far to its lower left is Altair, and just below the letters Li and Live, that one star that's almost touching the top there is Deneb, and forming the Great Summer Triangle with Vega and Altair. Gorgeous view. This all sky is stunning, and in true color too. It's showing it just the way it would look to the eye.
And actually, the slight yellow tinge, you say it's real color. It is. The slight yellow tinge that we've got tonight is we have a little bit of Sahara dust blowing over the observatory. It's called La Calima, and sometimes when that gets bad, we have to close up the telescopes because literally we've got dust falling out, Sahara dust falling out. So, and as Bob said there, that is not a streak of cloud going through the middle of that image. So from the bottom right, going all the way up through to the live badge, that is the Milky Way. It's the star clouds and the dust clouds of our huge spiral galaxy kind of seen edge on. Bob, what time does that beautiful trio of Mars, Saturn, and the bright star Antares kind of rise locally? It's about 2:40 a.m. Locally at the observatory. So what time would people be able to see this?
It'll clear the horizon just around nightfall, but of course the horizon is low. Very few people have oceanically clear views to the southeast. You want to give it a little time to come up. And that part of the zodiac doesn't rise right straight up. It rises very much at an angle to the upper right. So even an hour after it's risen, it's not very high. So give it 2 hours after it's risen. Wait till 10 o'clock or 11 o'clock, and then you'll see that triangle just beautifully. Mars, the brightest of the objects. Antares, matching it in color. The name Antares means the rival of Mars, because remember, Ares was the Greek name for Mars. Ant, just like an antonym or antifreeze or anti-anything, antipasto, antipasto doesn't count, means the opposite. So we have the rival, something that's battling Mars in that red star Antares. We have Mars of the same color and Saturn there too. My goodness, just gorgeous.
Yeah. So that's absolutely fabulous. Now, Bob, what are your thoughts on whether or not Mars has ever harbored life?
Well, you'd think that if it had, there should be some fossilized remnants. And you might recall that NASA got all excited thinking they had found a fossilized bacterium in a Martian, in an asteroid that really was a meteorite that had landed from Mars named, let's see if I remember it, ALH 84001. That had sat in Antarctica for 16,000 years, plunged into the ice, worked its way back to the surface, was found by snowmobiling researchers, and NASA really thought they had found something that looked like a fossil of a bacterium. Later analysis showed that they probably was not a fossilized bit of life, but you'd think that would be there and we could eventually find it. So if there was life on Mars, I think we'd find a remnant of it. It would be a very exciting discovery, of course.
I can never help feeling when we talk about life on Mars, and I know a lot of people are great fans of these robotic missions with rovers going around, but I often think how much we could learn if we had a human set of eyes just walking a mile on Mars, how much we could uncover where we're not looking at through this tiny little image, which has taken minutes and maybe hours to get through to us. Now, even if there isn't any life on Mars in the current epoch, there could be soon a couple of private companies are offering people the chance to be the first to set foot on Mars in a one-way mission. Hundreds of thousands of people signed up for the opportunity. Now, Bob, late last year, I think it was, you got a chance to speak with Josh Richards, one of the finalists for that Mars One mission. Now, Josh, unfortunately, is off chasing storms in the American Midwest this week and couldn't join us. But we have a bit of that interview to play for everyone. This is Bob's interview with Josh Richards.
Josh, you've really signed up for a one-way trip to Mars. Why did you do that?
It's been primarily about sort of setting out and doing something a bit different. I knew that we could physically get to Mars. I've known that for quite some time as part of my physics degree. I had sort of gone off on a bit of a sideline and done other things and worked in stand-up comedy for quite some time. And I'd actually tried to bring the two things together to write a comedy show about sending people one way to Mars when I discovered Mars One.
So Mars One is working on its own independent trip to Mars. It doesn't matter what the Chinese or anybody else is doing. Is that correct?
Well, I mean, it'd be fantastic to work with everybody. And I know that Mars One has a series of folks who work for NASA who are there as advisors. But again, it's deliberately not associated with any individual government. Mars One very much sees this as something for all of humanity rather than just, an achievement for one individual country. It would be great to see everyone working together the same way we do on the International Space Station. But there's even politics on the space station. You don't see the Chinese on the International Space Station. And Mars One's deliberately trying to avoid that sort of thing.
Huh. Your answers are so rational. I wondered whether a finalist going to Mars, you're going to get somebody with, very bad credit card debt.
It's interesting looking at the folks that are still involved. We do have some unusual characters, and I think character adds to the kind of mission that we're involved with. But there are some very reasonable people that are involved. I don't know if I include myself in that, but there's some very intelligent, very, very wise people who see this as being vitally important.
That was a very modest Josh Richards. Great interview, Bob. That was the interview that you did on our broadcasts when we were covering the release of the movie The Martian. So I'm not sure if we're hearing people's favorite Mars-related movies. Come on, we want to hear those to Twitter, to @slooh. Now, Bob, would you go to Mars if you had the opportunity? Not necessarily just a one-way ticket, but would you like to set foot on another planet?
Well, I guess on paper I would. It's awfully dangerous. I'm not afraid to leaving Earth. You and I, of course, have in common that we're both pilots and airplane owners, or at least you were until recently an airplane owner. I still am. So we're not afraid of getting our feet into the air. But Mars is really dangerous. It's got a radiation flux that's so high that Shannon Lucid, the longest serving U.S. woman astronaut in space, quotes that in a 2-year mission, as much as 20% of the brain cells could be destroyed by the radiation. And
wow.
This is downright dangerous. You can't breathe the air. You don't have medical facilities. The pizza's terrible. You'd have to really suffer a lot of privations being on Mars. And honestly speaking, I think I'd leave it. To others, frankly, to go. And as for the one-way mission, forget it. We're going to send our producer Trisha there because she's up for this. But for me, no. I think I'll just watch it on the telly and watch the braver people go. And
And Trisha, our producer, has just chatted to me saying, "Hell yes!" So she's going for that. I would be as well. I would. Gosh, the opportunity, Mr. Elon Musk, if you're watching, send me a ticket, please. More than happy to join you. Bob, any last thoughts on the planet Mars before we hop off to some other people who are planning actually missions to Mars?
Well, yes, it's a very exciting opposition. I love the fact that it's in Scorpius, right near its namesake Antares. It's near Saturn, which is coming to its own opposition in a matter of days. So it's rare to
Yes.
get two planets essentially in conjunction or very close to it that are both coming to their closest of the year at the same time. So Mars is only part of the story. This is a great planet time of the year happening just when the weather is getting more pleasant for observing. Of course, here at SLOO, the weather doesn't matter because no matter how cold it is, we can just stay comfortably in front of our computer monitors and watch the great images. But yeah, it's definitely a major event in 2016.
Well, Bob, thank you very much for joining us tonight. We will see you again on Friday, I think it is, for that Saturn opposition show. That's going to be a really exciting one. There's just so much to talk about that beautiful, beautiful planet. So, but thank you
Yes,
very
I'm
much,
looking
Bob, for
forward to it.
joining us
It's
tonight.
great with the rings, and it's twice the size of Mars. You know, if you're looking at this SLOO image and saying, well, Mars looks kind of small, it is small. It's only 4,200 miles in diameter. Saturn is twice as large appearing. It's much larger than that in reality, but it's going to be a much more substantial and I think breathtaking image. I'm
Yeah,
looking forward to that on Friday.
for sure. For sure. Okay, thank you, Bob. That was SLOO astronomer Bob Berman. Members can watch Bob's 2 shows each week on Tuesdays and Thursdays on SLOO's live channel. They're always a great deal of fun because Bob picks the objects that he's going to point the telescopes to, and he's a wealth of astronomical information. Now, as we look at this live image coming from the flagship observatory in the Canary Islands, it's 8,000 feet up on a volcano in the Atlantic off the west coast of Africa, and we get beautiful, beautiful conditions up there. And as Bob says, you know, we were talking about it on last week's show actually. Mars through a telescope can actually be quite disappointing, but we have got the lovely capture that maybe we'll show again shortly. But Saturn will knock your socks off on Friday. Now, we are going to take a short commercial break, but coming up, I'm going to be speaking to Nicole Willett from the Mars Society. But before we go, I want to remind you of a big show that we have coming up. That show on Friday, June 3rd. We are going to be taking a live look at the most stunning, the most beautiful planet of them all, the ringed planet Saturn, as it reaches opposition, the best time of the year to view it. Now, SLOO astronomer Bob Berman and I are going to be discussing some of the fascinating facts about that planet, and we'll talk about its many moons, some of which have been found to contain huge underwater or undersurface oceans. So don't go away, we will be right back. Welcome back to SLOO's show of Mars. Look at that. Mars, the rusty old planet from the Canary Islands Observatory. Mars is at its closest tonight, as it has been for over 10 years. Absolutely awesome. Anyway, Mars has captured the imagination of humans for generations. It's been seen as a powerful god in ancient times, and more recently as a possible outpost for future human exploration. The future of humanity's existence on the red planet is at the heart of the efforts of what's called the Mars Society, a group dedicated to advocating human exploration of Mars. And I'm delighted to welcome Nicole Willett, the Education Director for the Mars Society. Nicole, thank you very much for joining us tonight.
I'm very happy to be here. Thank you for having me.
Now, some people won't have heard about the Mars Society. What is it that you do, and why are you doing it?
Well, Dr. Robert Stubrin is our president and founder, and he has a passion to advocate for humans to Mars mission. And he's been doing this for years and years. And we don't build rockets, but we bring all the rocket builders together in a convention each year. And NASA scientists, Elon Musk has spoken at our convention. The Mars One guys have been there several times. So we bring everyone together to discuss ideas and collaborate and let the public know what we're up to and how fast can we get humans to Mars.
Now, I don't know if you heard me talking to Bob, but, you know, robotic missions are great, and we see these rovers the size of huge 4x4 vehicles trundling along on the surface of Mars. And whenever I see any images of them and I see how slowly they're crawling, they look like a tortoise, and they look like almost a blind tortoise. And the thing that always goes on in my head is, what could a human with human hands and feet, and most of all, eyes, do? How much science, how much knowledge could we gather up? Is this why the Mars Society is really advocating the human exploration of Mars rather than more robotic missions?
Yes, it's been said by many Mars scientists actually that what a human can do in a couple of minutes takes a rover 2 or 3 weeks to do. So humans have the wherewithal to make decisions that robots just can't, no matter how much we program them, no matter how much AI they say we have. They just aren't human. They just don't have fingers, and they can't do the things humans can do as quickly.
And of course, these missions have to be programmed because it takes, a heck of a long time for the signals to come back and forward. And the other thing, of course, I always think about is, the available bandwidth for what kind of images can they send back. And we never see, do we? We never see some fabulous video footage from one of the rovers. And it's because it's so big and actually is of little scientific importance. Now, what are we looking at here? So what are the Mars Society doing to further this ambition?
So this is a video of the Mars Desert Research Station in Utah, and we have college students and other people participate as well, come and do 2-week rotations, and this might be some video on Devon Island in the high Canadian Arctic. Okay. We have two analog stations. One is in Utah and one is in Canada. And people go there for rotations to do science and act like they're living on Mars and see all the different kinds of things that can be accomplished under stressful circumstances. You see, they have their sim suits on. They have to wear those every time they go outside of the hab. The hab is 16 feet in diameter. It's 2 levels. There's the bottom floor there where they're living as a community together. And then the upper floor is where their bedrooms would be. So it's a really, and here's the floor plan for that coming up here. We're the only organization that has 2 analog stations in the world.
Ah, okay. And you talk about an analog station. What really is in there? Is it sealed? Is it having to recycle food and water? And does it have the kind of human systems in it, or the mechanical systems in it that would have to be put in place on Mars?
It is as close as we can get to simulating a Martian environment. It's not pressurized because we don't have to pressurize it, but they do have to go through a process simulating what it would be like to put on the suit, be pressurized, and then go outside. And so it's as close, all of the things are as close as they can be to simulate what a Mars mission would be in a hab.
Now, what do you make of the Mars One project. We spoke about this earlier. What do you make of that at the Mars Society?
Well, I always say that if whoever gets there it's wonderful for humanity. But personally, I don't think they have the funding in place to accomplish all of the things that they want to accomplish. I think technologically, we definitely can go to Mars. I heard Bob Berman saying earlier he would want to watch from the television, and many people would. But many people do want to go, and I think we can do it. I know we will do it, whether it's SpaceX or Bigelow or a combination with NASA or someone else. It will happen. I just do not believe that Mars One has everything they need in place to get there in the timeline that they have set up.
Yeah, I mean, it's multi-billions of dollars, isn't it?
Yes.
Now, you were talking
About
a little
10
bit earlier
billion, about
about
10 billion to send 6 people or
10.
so.
Wow.
Right.
So, I mean, I'd still sign up for it, but rather than have the money, actually. But you were talking about collaboration earlier on. You've got an event coming up, haven't you? Which is, and you said you pull rocket scientists together. Is that what this event is?
Yes, we have an annual convention this year. We're going back to Washington, D.C. It's our 19th annual Mars Society convention.
Wow.
It'll be held at the Catholic University of America. We have, here's the poster for it, and you can go to marssociety.org for all the details and more information. But we bring together scientists from all over the world, literally. Many NASA scientists are there always, every year. And there are some of them have been released to the public. All of them haven't been yet because it's still early in the process. And so we bring them all together. We have a 4-day convention, and we have plenty of plenary speakers. We have track talks. We have a banquet speaker with a big banquet on Saturday night, and then we wrap things up on Sunday. It's from September 22nd to 25th.
Fabulous. That sounds like an event that Slooh should be at to do a live broadcast from. So, by the way, obviously,
you can come and do a broadcast.
Our producer Trisha Ennis, she is desperate to do a stint in your analog station. So that would be brilliant if we could share that experience of what you're doing at the Mars Society with the Slooh viewership, you know, live from the station, either in Utah or elsewhere. That would be a fabulous event that we must follow up. So how can
officially
other people
invite you?
Thank you very much. How can people get involved if they're interested, or how can they support the Mars Society?
There are many ways to support the Mars Society. You can join on our website. Join now as an official Mars Society member. You can always make donations to any organization like that. Which there's a donate button on our website. We always enjoy having volunteers that are ready and willing to help do public outreach and some other odd jobs here and there. So volunteering is a big part of our organization. There are many things that we do that volunteers can help with. And so just go to marssociety.org, and you can email info@marssociety.org and ask for more information. If you're not sure if you're the right fit, email us and we will let you know.
Oh, well, hopefully you'll get a few new supporters from our show tonight. Now, before we let you go, Nicole, we like to ask our guests here at Slooh, what inspired them to get interested in technology or space, astronomy, or whatever it may be? What was it for you? You know, some people have said it's been a sci-fi movie or a book that they picked up as a kid, or my one is just one fabulous science teacher. But what was it that inspired you to get involved in astronomy and space?
It was a little bit of a combination of all of those things you mentioned, but there were some major points in my life. I watched Star Trek, the old series, all my life with my mother and my sisters, and that was wonderful. And of course, Star Wars. But I read the 1988 National Geographic magazine article titled Mission to Mars when I was a sophomore in high school. And that moment changed my life. And I was obsessed with it ever since then. And soon after, I discovered the Mars Society. And in 2012, I came on board after the Pasadena convention. And I've, been a Martian ever since.
That is a fabulous story. I love the fact that it was, a single copy of National Geo, that just clicked. And so many of our guests have this kind of seminal moment. It is this spark. It's when the spark for you that just fits your brain and your personality goes off. It's a wonderful feeling. And, I wish everybody could experience that, don't you?
Yes, I'm an educator during the day, and I teach astronomy full time to high school boys. And
Mm.
I tell them all the time, you don't have to become an astronomer, but find your passion, follow your passion, whatever it is. When you
Yeah,
feel it, you're going to know it and do it. Whatever it is, do your best at it.
absolutely.
So,
Well, I'm sure that you are inspirational to both your students and people involved in the Mars Society. So, Nicole, thank you so much for joining us tonight, and we'll follow up on the convention in September.
wonderful. Thank you. Mars looks beautiful.
It does, doesn't it? In this is
Yes.
our live image from the Canary Islands 17-inch telescope. It's not the best telescope to look at a planet with, but that's a pretty cool view, isn't it, tonight? So
It's beautiful.
thank you for joining us, Nicole.
Have a good night.
Thank you. Wow, what an evening we've had. That was the Mars Society. I hope that was new to you. I came across them actually looking at, there was a news article with a lot of those pictures and videos that we showed there. And, it's inspirational what they do. And, there's a lot of people like me and Nicole, and the Mars Society who really favor it. It is more costly, but human exploration. Forget about the risk. Bob was talking to us about the risks. You know, the kind of explorers that inspired me as a schoolboy, they didn't care less about risk. It's in our human nature to go and explore, and we need to do that in person. We need to go there. We need to feel the Martian dust in our gloved hands, and especially we need to see it with our own eyes. What an hour of one human being on Mars could achieve versus a multi-billion-pound rover is it doesn't equate, does it? Anyway, I hope you've enjoyed our coverage of Mars Rocks tonight at its closest for over 10 years. Now, before we leave you, I wanted to remind you of a show we have coming up later this week, Friday, June 3rd. We are teaming up with our friends at Astronomy Magazine to bring you the opposition of Saturn. It is going to look awesome in the telescopes. The way Saturn is tilted towards Earth at the moment means we see all of the rings on full display. They're tilted right towards us. It really does look fabulous in the telescopes. So please join us Friday 3rd. You can see there 8 p.m. Eastern. That's 5 p.m. Pacific. Now, don't forget, if you've got any questions or send us your own Saturn images or poetry or music, anything that's inspired you that's related to Saturn, then tweet that to @slooh, and we will be sure to feature it in the show. So anyway, that is it as we look at this last image coming in from the 17-inch telescope in the Canary Islands. Don't forget, Slooh members can control this very telescope. It doesn't just look at planets, it looks at galaxies and nebulae and star clusters and all manner of things. Wow, I think there's some good comets as well to look at the moment. So why not come along and join us in the Slooh community to control those telescopes? But that is it for now. I'm Paul Cox. This has been a Slooh astronomical production. We will see you soon, hopefully on Friday. Goodbye for now.